Hello everyone, in this video we are going to discuss an application of logic gates, that is adders. We are going to see what are the applications available, and we are going to specifically discuss about adders and what are the different types of adders available. Design and maintenance of digital computers are greatly facilitated by the use of Boolean algebra and computer hardware. So when you see modern computer, or you can say digital computers, you will have some design of circuits. Okay, so this is mainly used, that is facilitated by Boolean algebra and logic circuit. So when you see diagrammatically how the connection from one gate to another gate is been applied, the same thing can be done physically in digital computers. So that's the reason they say this. Logic networks are designed making use of logic gates. So logic networks, so if you are going to use some networks, okay, logically, the designing part will be done using this logic gates. So that are the applications of logic gates. So we are going to specifically say adders. Okay, so under adders you have two types of adders, half adder and full adder, and then other two are encoders and decoders. So these are the applications of logic gates, which is used to design logic networks. Okay, so first what you are going to see is about adders. Generally, what is an adder? ALU, that is arithmetic logic unit, which is available in the motherboard. Okay, performs all arithmetic and logical operations. That's what we already know. Okay, so all the arithmetic and logical operation is done in the ALU, that is arithmetic logic unit. But ALUs do not process digital numbers, that is decimal numbers. They process only binary numbers. So adders also will work on binary numbers. So everything, whatever you give it for arithmetic and logical operations, it will be converted to binary, and then the result will be transferred back. Okay, that's what the function of the arithmetic logic unit. So adders also use binary numbers for doing the performance. Okay, so perform some arithmetic and logic operations. The adders also will do it in binary numbers. So there are some basic rules for binary addition, which you already know. Okay, that is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 0. So this is a general rule. 1 plus 1 is 10. Okay, so we already discussed in some previous videos about addition of binary numbers. The same thing, you will have 2-digit number. Since you have 2-digit number, one will be the sum and another one will be the carry. So the rightmost digit is the sum and the left digit is the carry. So you can write like this. So carry, you have to write 1, and then sum you have to write 0. So 1 0. Next you got 1 plus 1 plus 1, that is nothing but 11. Okay, so in that rightmost digit is the sum and the left digit is the carry. So 1 1. So this is how you will be writing the binary values. Okay, that is the column carry and sum has to be used in adders. The result having 2 bits. Okay, right bit gives the sum and left bit gives the carry. That's what we just discussed. Okay, now we are going to see about half adder. So what is an half adder? It is a logic circuit that adds 2 bits. That means 2 numbers. Okay, so when they ask you the definition of half adder, you have to write this. It is a logic circuit that adds 2 bits. Okay, it produces the output sum and carry. So you will have 2 columns. That is, normally you will have 1 column for output, but adders you will have 2 columns. One will be named as sum and another one is named as carry. The Boolean equations for sum and carry are sum equal to x plus encircled y. We call it as x or y, and carry equal to x dot y. So that is nothing but dot symbol represent and. So x and y. Okay, so to represent it in truth table, you have to draw the truth table with 2 values, 2 variables, that is x and y. Okay, that are the input. Okay, and write all the combination, and then 2 columns for output. One will be the sum and another one will be carry. So here you are going to add it. So 0 plus 0, as per the rule, it is 0 0. That is, the value is 0. So sum value is 0 and also carry value, obviously it will be 0. 0 plus 1, the sum value will be 1 and carry will be 0. Okay, you are not going to carry over to another, that is a previous digit. So obviously the carry value is 0. Again 1 plus 0 is 1. Okay, sum value is 1 and carry value is 0. Now you got two digits, that is 1 plus 1 is 10. So some value will be 0 and the carry value will be 1. So this is the truth table what you got for half adder. Okay, just add these two columns, you will get sum and carry values. Now when you notice this sum, okay, it is nothing but the result of XOR gate. Okay, 0 1 1 0, this represents XOR gate. That's the reason you got sum equal to x or y. Okay, that's the reason you got this. Okay, and you can notice the carry, okay, column. You can notice that you got all zeros and 1. This is nothing but it reflects the AND gate. Okay, so it replaces the AND operation. So you will have all zeros except the last one. Last row is 1. That's the reason you got x and y. So these two are the results you are going to get when you add. Okay, half adder. Using half adder, you are going to add 2 digits. Okay, 2 bits number, and then you are going to get the sum and carry. Now when you represent it to a gate, or you can call it a circuit, because you got more than one gate, you may call it as circuit. Okay, you have two input, that x and y. Okay, one will be carried, one will be connected to an XOR gate, that is sum. You can write x or y. Okay, and another gate is nothing but AND gate. Okay, which will be the carry. X dot y is the carry. So this is the half adder logic gate. Okay, so if they in the exams they ask you to draw the truth table and the logic circuit diagram, logic gate diagram, you have to draw this. Okay, this is what about half adder. Now we are going to see about full adder. It is a logic circuit that adds 3-bit numbers, that is 3-digit numbers. So obviously you will see x, y, z. Okay, the sum and carry, you are right, sum equal to x, XOR y, XOR z. Okay, so that's how you are going to write the expression for Boolean expression for sum, and carry will be, you have got two numbers which is be added with, that is you are going to have the AND operator in between. So x dot y plus y dot z plus z dot x. So this, just remember this, so that you will have all the 3 combinations. Use AND gate in, that is AND operator in between, and join it with OR operator. So x dot y or y dot z or z dot x. Okay, so this is how you are going to write the Boolean expression. Now you come to the truth table of full adder. You have got 3 variables, that is 3 input. Okay, 3-bit number. So you will have all the combinations here. Now you are going to find draw 2 more columns for output. One will be sum and another one will be carry. Just add these numbers. So 0 plus 0 plus 0 is 0. 0 plus 0 plus 1 is 1. So sum will have 1 and then carry will have 0. And then you got 0 plus 1 plus 0 is 1. So sum will be 1 and carry will be 0. Then you got 0 plus 1 plus 1. So you will get 10. So sum will be 0 and carry will be 1. Then you got 1 plus 0 plus 0, again it is sum is 1 and carry is 0. Then you got 1 plus 0 plus 1, so you got 10, right? Sum will be 0 and carry will be 1. And then you got the next row is 1 plus 1, that is 10. 10 plus 0 is 10 again. So you will get sum equal to 0 and then carry as 1. Then you got 1 plus 1 plus 1, that is nothing but 11. So sum is 1 and carry is also 1. So this is how you are going to write the sum column and then the carry column. So you can see that wherever you have ones, for carry has to be written like this. So you can see that y is z, you got 1 1, right? So you are right, y z, okay, for carry column. And then you got x and y z here. So 0, you got y as 0, so you are not going to include y here. So you are going to use x and z. So that's how you got this x z. And next column you got x and y as 1, so x y, and 0 for z, so you are not going to include z here. Okay, so you got x y. So combine all these and then you will get it as this expression will come. For carry you will get x y plus yz plus zx. So this is how you got this. And some value you already done the half adder, which has 2 bits, which is nothing but XOR. You are going to use XOR gate, right? XOR expression. Here you are going to have 3 bits. So join all the 3 with XOR. That's the reason you got this expression. Now you are going to represent it as an logic circuit. So you will have three variables. Okay, so you draw three lines. First join all the three to an XOR gate. So that is the sum. Okay, that is nothing but X XOR Y XOR Z. Okay, so that is the first gate what you're going to draw, and then the remaining. So join X and Y first. So you got X and then Y. So join this and then you join it to an AND gate. So you will get XY. And then you got YZ. So join Y and Z, you will get. Okay, you can see here Y is joined and Z is joined. So you got you have got an AND gate here. So you will get Y dot Z, and then you got Z dot X. So the last one you got X and then Z. So join both to an AND gate. So you will get Z dot X. Okay. So three terms. Then you are going to join it with an OR gate. So you can see that plus sign in between. So join it with an OR gate. So that is the carry. So carry will be XY plus YZ plus ZX. So that is the carry. So this is the representation of full adder. Okay, logical circuit. So in exams they ask you either half adder, you have to draw the truth table, and or they may ask you any one. Okay, or they'll ask you full adder, draw the logical circuit, or they'll ask you to draw the truth table. So just understand, go through it again. Okay, so you can try it in the notebook. Okay, try to draw all the circuit and truth table so that you'll remember it. So hope you understood this video. We'll meet you in the next video. Till then, thank you.